Okay, ladies and gentlemen, today we are going to start with doing science, and we're going to focus on scientific notation and unit conversion. Scientific notation, you've probably used it before. It looks something like this: 4.5 times 10 to the, let's say, 6th power. This is something you've done over and over, so we're going to practice a little bit more. It's a way of writing either really big numbers or really small numbers, and it uses powers of 10. The decimal point is put behind the first non-zero number. That's a big deal. Just one number and then the decimal point. Not two numbers, not three numbers, one number. The power of 10 is the number of times it gets moved to get there. A number that began large, okay, if it's bigger than 1, has a positive exponent, and a number that's small has a negative exponent. So we're going to look at some of these examples here in a second. The expression always goes like this: a times 10 to the nth power. Fairly simple. So here, if we have this 1,000 or 12,457 point, let's do some scientific notation. So here we have this big number, 12,457.656. First off, we're going to do all of these to 3 places, okay? Just so that we don't have so many numbers. We would start with the decimal point, and we would move the decimal point right here until there's only one number kind of before it. So I make all those moves, and it would be 1.25 times 10, but how many decimal points did we move it? How many places? So 1, 2, 3, 4. So that's to the 4th power. And that's a positive 4 because this number is greater than 1. It's a huge number, so it's going to have a positive exponent. We do the same thing for the second one. We take our decimal right there, here it is, and we're going to move it over until we get to 1 digit. And keep moving. Oh, there it is, 6. So we'd write 6.54 times 10. Then how many did we actually move it? 1, 2, 3, 4, 5. So we're going to say to the negative 5th power because this number is way less than 1, okay? Way less than 1. Now for 128.9, I'm going to move this decimal over so we just have one digit in front of it. So it's 1.289, let's just do that, times 10. What power? How many did we move it? 2. So we say positive 2. It's positive 2 because this number right here is greater than 1. Now if we look at the next one, is this number greater than or less than 1? Obviously it's less than 1. So you know what? It's going to have a negative exponent. And what is the negative exponent? Let's start by 1, 2, 3, 4, 5, 6, 7. So it's going to be times 10 to the negative 7th power. But what goes before? 7.53. That's the basics of actually writing something in scientific notation. But sometimes we have to go backwards. Alright, what I mean by backwards is sometimes a number's written in scientific notation and you have to put it into standard notation. Now, of course, these beautiful numbers are not actually written correctly because my computer transferred things over. All of these are supposed to be multiplication signs, times, times. And this should be not 104, but times 10 to the 4th power. Now, is that number going to be greater than 1 or less than 1? It's got to be greater because that's a positive exponent. So what we're going to do is we're going to move this decimal point over 4 places. 1, 2, 3, 4. And that would make this 1, 3, 7, 0, 0 meters. Alright, the same thing's going to happen here. So this is to the 2nd power. That means, okay, that number is going to be greater than 1. So we're going to move the decimal place 1, 2. So this becomes 287.5 grams. Alright, now all of a sudden we have a negative exponent. Negative means it's going to be less than 1. So the only way we can move it is we move it in front. And we moved it 1 time, 2 times, 3 times, 4 times, 5 times. So this becomes 0.0000875. Now, how can we double check that? It says to the negative fifth. Well, let's see. If we move us 1, 2, 3, 4, 5. We're back there. Perfect. And the next one, also less than 1. So zeros are going to come before the 7. We'll go 1, 2, 3. So it becomes 0.007005. All right, so that's scientific notation in a nutshell. Go online and you go to this PowerPoint. You can click on this little thing right here that says Scientific Notation Practice. It's going to take you to a website. And in fact, this will be part of your homework. Part of homework. Woohoo! All right, so that's one way you can practice some scientific notation on your own. Now we're going to move on. Our next thing is called converting units, okay? There are lots of different names to it, but I call this truth tables. If you use a truth table, it will always tell you the truth. They're awesome, and you're going to love them. All right, here's a whole bunch of words to talk about before we go into this. Often a measure is more convenient in one unit, but is needed in another unit. For example, I have a friend who lives in France. That friend has a recipe for really awesome crepes. However, all of the measurements for her crepes are in grams and liters and all that nonsense, and I don't have those cooking utensils. So I need to convert units. The fancy word for converting units is dimensional analysis. It is fun to say dimensional analysis, but really I'd rather say truth tables. Okay? It's easier and it's fun. Okay? So here we go with that. Kind of an example. What we do is we use equivalents in truth tables. For example, 1 foot equals 12 inches. You know that. But we put them on top of each other. 1 foot equals 12 inches. That's it. I can also put, get this is crazy. I'm going to do it right over here. I can write it like this. 12 inches over 1 foot. And basically this means this equals 1, okay? They're equivalent. They cancel out 1 to 1. So it's 1. It doesn't matter if I write it foot over top of inches, inches over top of foot. And that's the beauty of analysis. So here's the deal. If you want to multiply anything by 1, the answer is the same. So for example, let's say I have 27 inches and I want to know how many feet that is. If I multiply 27 by 1, it's the same thing. But if I take 27 and multiply it by 1 over 12, which is just 1, okay? The inches cancel out and we end up with feet. It's amazing, okay? But that's kind of a basic thing, and some of you might get it really easy, but here we go with some. So here are the steps for using dimensional analysis or truth tables. The first step is to always write down what you're given, and then to number 2, write down an answer blank and the desired unit on the right side of the problem space. Sort of like this. A truth table I always use like this, and this is where I'd put my X and then whatever unit I have. Okay? In the second part of the truth table, I'd use the equivalents, okay, the conversion factors to cancel out the unwanted unit and get a desired unit. To calculate the answer, number 4, multiply your numbers across and divide down the bottom. Okay, so that's the basic idea. Let's do some examples. Before we do, we have some common equivalents here. I will generally always give you the equivalents, but you know some of these. 1 foot equals 12 inches. 1 inch is 2.54 centimeters. The one we're going to use in our first problem is 1 pound equals 454 grams. All right. Here we go. How many grams are equal to 1.25 pounds? So I know just before we said 1 pound equals 454 grams. All right, that's our conversion factor. So what I do when I make a truth table or do dimensional analysis is I start with the number they give us. So they give us 1.25 pounds. And I'm going to write the, abbreviation there. And I make a table, okay? And it looks kind of like this. And here's my unit, pounds, okay? I don't want pounds anymore. So I'm basically doing math with the units. I can put pounds down here, and the pounds will cancel out. Awesome. If my conversion factor here's my conversion factor, it has pounds, I can put the grams up on the top. And now I just continue with the number. 1 pound on the bottom, 454 grams on top. So now, to do the math, this line right here, up and down, is kind of like the multiplying line. And this line is like a fraction. It's like a dividing line. So all we would do is take out our calculators, put 1.25, and then here's the multiplying line, times 454. And then here's the dividing line, divided by 1, which we don't really have to do. And I ended up with 567.5 grams. Does that make sense? It's more than 1 pound, so it should be more than 4.54 grams. Perfect. Circle my answer, and I'm good to go. So let's try it again. Next question. If a pound of apples costs 79 cents, then 5.3 pounds will cost what? So our conversion factor here is not 5.3, it's 1 pound equals 0.79 cents. Okay? So if we were to start this, we would start with the number they gave us, 5.3 pounds. And that's the first part of the truth table. Then I need to have a second part, and I'm going to put pounds on the bottom, okay? And I'm going to put dollars up here, okay? So pounds cancels out. How many pounds? 1. What's the price? 0.79 cents. And I'm going to do a little math here. I'll take out my calculator. Remember, this is the multiplying line. This is the dividing line. Okay? 5.3 times 0.79 equals $4.187. Okay? So $4.18, I can't really say 18, and the bank would round that up, so I'm going to take $4.19 for all of those apples. Okay? So there we go. So there's another problem. So here we go. We'll try example. Example number 3 says 1849 yards equals blank miles. Oh man, we got to know some things, okay? There's a lot of things we have to know. It gave us a hint though, that 1 mile equals 5,280 feet. So I'm going to start my truth table with this number that they gave me, 1849 yards. Okay, I don't want yards anymore. I don't have a conversion factor with yards, but I need to get rid of yards. Does anyone know how many feet are in a yard? I do. 1 yard has 3 feet. So I've done that, and guess what? I can make the truth table even longer. Now I don't want feet anymore. So I do 5,280 feet right here equals 1 mile. Now you can do some amazing canceling because yards is on the top of the fraction and on the bottom. Cancels feet, and you're left with miles. Now, ladies and gentlemen, some of you will say, this is stupid. I don't need to do all this work to convert yards to miles. I can just do it in my head, and I can just use my calculator. You're absolutely right, except your teacher can't grade you, and I won't know what you're screwing up. So, ladies and gentlemen, you have to do truth tables. And here, this might help you do them. That's a smiley face. Truth tables are fun. All right, get used to it because they're not going away. So, here we go. How do we do the math now? I take 1849 and I multiply it by the next number, 3. Okay, and I can divide by 1, but I don't need to. Okay, and then I multiply by 1. Okay, and I divide by 5280. And I end up with this wonderful number, 1.05. I'm going to round there. 1.05 miles. There we go. Oh, conversion factors and truth tables. They're my favorite. Let's try a couple more. Alright, if a U.S. car advertisement brags that an SUV gets 26 miles per gallon on the highway, and the same car would get, in Europe, kilometers per liter. I don't know. Let's see what this looks like. This might be a huge truth table. We start with 26, and I'm going to write 26 miles here over 1 gallon, because that's what that means. And I'm not wanting miles per gallon anymore. Instead, I'm wanting kilometers per liter. So what I'm going to do is I'm going to start with miles. Do they have a conversion to there it is. And I can put miles on the bottom and kilometers on the top. Cool. And when I do that, that's 1 kilometer, 0.621 miles. Awesome. And I've canceled out miles, and I'm here with kilometers per gallon. So kilometers on top. I don't want kilometers per gallon. I want per liter. So I need to figure some more stuff out. I've given gallons. I want to get rid of gallons. So the only thing is I can put gallons here on top. Do I have a conversion factor with gallons? Sure. I have gallons right here. Gallons to quarts. So I know that 1 gallon is 4 quarts. And I'm still not looking for quarts, even though gallons and gallons have canceled out. Now I'm at kilometers per quart. I want kilometers per liter. So I need one more section of my truth table. Okay? And I know from this conversion factor right here that 1.057 quarts equals 1 liter. Now that I have that, everything cancels out and you're left with kilometer over liters. Not bad, but what about the numbers? So I start with my 26. So this is 26, and I multiply, okay, by 1, but there's nothing there. But I have to go to the bottom. That's dividing by 0.621. So I divide by 0.621. And then I have this line right here. This is the multiplying line. Multiplying by 1. I don't need to do that. But now divide by 4. Done that. And then here's the multiplying line times 1.057. Hit equal, and I get 11.06 kilometers per liter. Woo woo! Good stuff. All right, we got one more example. Here we go. All right, next one. How many seconds are there in 1.4 days? And I didn't give you any conversion factors because I think you're smart enough to do this without them. 1.4 days. I don't want days anymore, so I'm going to put a part of my truth table, days. Have how many hours? We're going to do the conversion from hours to days. And before I put any numbers there, I'm going to do my conversion from hours to minutes. And before I'm done with that, I don't want minutes. I want to get rid of minutes. I want seconds. Now let's fill in some numbers. 1 day has 24 hours. You know that. 1 hour has 60 minutes. 1 minute has 60 seconds. So now check this out. Days, days cancel. Hours, hours cancel. Minutes, minutes. You're left with seconds. Sometimes it's fun to do math just with the units. So now we're going to multiply across. So here we go. All right, 1.4 times 24 times 60 times 60. What do we get? A huge number. 1,2,0,9,6,0. Oh man, that's such a pain in the butt. I think I should write it in scientific notation. How about this? 1.21 times 10 to the 1, 2, 3, 4, 5th power seconds. Woohoo! There you go. That is truth tables and scientific notation in a nutshell. Hopefully that can help you out if you missed it in class. Have a good day. Bye.